The engine that made Lexus untouchable required Toyota to spend over $1 billion in development. Engineers tested prototype engines for 2.4 million miles before approving production, and one test motor ran continuously at redline for 100 hours straight without failure. But why did Toyota ban their own engineers from benchmarking German V8s? How did they accidentally create the world's most overbuilt engine? And which secret motorsport program proved this V8 could survive anything? These are 20 jaw-dropping facts about the Toyota 1UZ-FE that will blow your mind. Number 20. The billion-dollar gamble. Toyota's board of directors nearly killed the 1UZ project 3 times before it reached production. The development costs had spiraled past $1 billion by 1987, making it the most expensive engine program in Japanese automotive history. Chief engineer Ichiro Suzuki faced intense pressure to abandon the project and use an existing V8 design, but here's what saved it. AG Toyota himself intervened, declaring that Lexus needed an engine that would embarrass Mercedes-Benz. The board gave Suzuki one final chance with unlimited resources. He assembled a team of 1,400 engineers, including 300 stolen from Honda and Nissan. They worked in a secret facility codenamed Circle F, where even Toyota executives needed special clearance. The gamble paid off spectacularly when the LS400 launched, but few know how close this legendary engine came to never existing. Number 19. The Mercedes ban. Toyota's management issued one of the strangest engineering directives in automotive history. Nobody working on the 1UZ could drive, examine, or benchmark any German luxury car. Not a Mercedes S-Class, not a BMW 7 Series, nothing. Engineers caught studying competitor engines faced immediate reassignment. Why such extreme measures? Toyota's leadership believed that copying German engineering would create an inferior product. They wanted something completely different, not a Japanese interpretation of a Stuttgart V8. This forced the team to approach every problem from first principles. Instead of copying Mercedes' iron block design, they pioneered all aluminum construction. Rather than following BMW's valve train, they created their own unique quad-cam system. The isolation strategy worked. When Mercedes engineers later disassembled a 1UZ, they found solutions they'd never considered. One German engineer famously said it looked like it came from another planet. Number 18. The impossible endurance test. Before approving production, Toyota subjected the 1UZ to the most brutal testing regime ever devised for a passenger car engine. The highlight? Running an engine at maximum RPM for 100 consecutive hours. Not idle, not cruise, redline. For perspective, most manufacturers test for 200 hours total at varying speeds. Toyota ran multiple engines at 6,000 RPM non-stop for over 4 days straight. The test cell sounded like a tornado. Engineers wore military-grade hearing protection just to check the monitors. After 100 hours, they expected catastrophic failure. Instead, they found normal wear patterns. The engine still made rated power. Compression remained within factory specifications. The only notable wear appeared on the timing chain guides, a part they immediately redesigned. This test became legendary within Toyota. Engineers from other divisions would sneak into the facility just to witness these screaming engines refusing to die. Number 17. The secret racing program. While the public saw the 1UZ as a luxury car engine, Toyota secretly campaigned it in the world's most punishing motorsports. The program started in 1990 when Toyota entered modified 1UZ engines in offshore powerboat racing. These boats slam into waves at 100 mph, subjecting engines to G-forces that would destroy normal motors. Toyota's entries dominated, winning 5 consecutive championships. But here's the craziest part. They used production blocks with stock internals. Competitors running purpose-built racing engines couldn't believe it. The 1UZ also powered experimental Le Mans prototypes that Toyota never officially acknowledged. These cars tested reliability at sustained 8,000 RPM, well beyond the factory redline. Data from these secret programs influenced the 1995 engine updates. Every Lexus owner unknowingly benefited from technology proven in racing boats and endurance prototypes that officially never existed. Number 16. The 6-bolt main mystery. The 1UZ's bottom end features 6-bolt main bearing caps, a design typically reserved for racing engines producing twice the power. Production V8s from Mercedes, BMW, and Cadillac used 4-bolt mains. Even Ferrari's V8s made do with 4 bolts. Why did Toyota over-engineer this component? Internal documents reveal the answer: future-proofing. Engineers designed the 1UZ to handle forced induction that never came. The original specifications called for a twin-turbo variant producing 400 horsepower. Accountants killed the turbo version, but the reinforced block remained. This explains why tuners can reliably extract 600-plus horsepower from stock internals. The 6-bolt mains were designed for boost pressures that wouldn't arrive for another decade. Toyota essentially gave customers a detuned racing engine without telling them. Number 15. The forged steel secret. Every 1UZ left the factory with forged steel connecting rods and crankshaft, components that cost 5 times more than cast parts. Mercedes used cast cranks in the S-Class. BMW's flagship 750i had cast internals. Why did Toyota spend the extra money? The answer involves an embarrassing failure during development. Early prototypes used cast components to save costs. During testing, an engine threw a rod through the block at 5,000 RPM. Shrapnel destroyed the test cell's wall. The failure happened in front of visiting executives who immediately questioned the entire program. Chief Engineer Suzuki made an executive decision. Every 1UZ would have forged internals regardless of cost. The bean counters protested, but Suzuki threatened to resign. The forged components added $400 per engine, but guaranteed the reliability that would define Lexus. No 1UZ has ever suffered a bottom-end failure in normal service. Number 14. The silent revolution. Toyota's acoustic engineers achieved something considered impossible in 1989, a V8 that ran quieter than most inline-6 engines. At idle, the 1UZ measured 38 decibels from the driver's seat, quieter than a whisper. How? Through obsessive attention to details nobody else considered important. The engine block featured ribbon patterns designed by a musical instrument maker. Each rib acted as a tuning fork, canceling specific frequencies. The oil pan used a sandwich construction with sound-deadening material between layers. Even the spark plug wire routing was designed to minimize electrical noise. But the real innovation was the accessory drive system. Toyota developed a serpentine belt with a special tooth profile that eliminated the whine common in luxury cars. They spent 6 months just perfecting the belt tensioner. Mercedes engineers who tested the LS400 couldn't understand how Toyota achieved such silence without adding weight. Number 13. The aluminum gamble. In 1989, building an all-aluminum V8 was considered insane. Aluminum blocks were for racing cars and exotic sports cars, not luxury sedans expected to last 300,000 miles. The tooling cost alone exceeded most companies' entire engine budgets. Porsche used aluminum blocks but charged supercar prices. BMW and Mercedes stuck with proven iron designs. Toyota's aluminum foundry required technology that didn't exist. They partnered with aerospace companies to develop new casting techniques. The deep skirt design added strength but complicated the casting process. Initial rejection rates hit 60%. More than half the blocks failed quality control. Engineers worked around the clock to perfect the process. The breakthrough came from an unlikely source, a technique used for casting submarine propellers. By the time production started, Toyota had the world's most advanced aluminum foundry. The weight savings justified every dollar spent. The 1UZ weighed 430 pounds fully dressed, lighter than many V6 engines. Number 12. The port design revolution. The 1UZ's cylinder heads hide engineering that wouldn't become mainstream for another decade. Toyota's port design team included former motorcycle engineers who approached airflow differently than traditional automotive designers. They created ports with varying cross-sections that accelerated airflow at specific points. The intake ports featured a unique tumble design that created vertical swirl patterns. This improved combustion efficiency and reduced emissions without sacrificing power. The exhaust ports used an anti-reversion step that prevented exhaust gases from flowing backward. Competitors' engines needed secondary air injection to meet emission standards. The 1UZ passed without any additional hardware. When Cosworth Engineering analyzed the heads in 1992, they declared the port design 10 years ahead of anything from Europe. The design was so efficient that modified 1UZ heads became popular upgrades for other engines. Racing teams bought Lexus engines just to steal the cylinder heads. Number 11. The VVTi innovation. The 1997 update introduced VVTi, variable valve timing with intelligence, but the system Toyota developed was unlike anything else available. While Honda's VTEC switched between cam profiles and BMW's Vanos adjusted cam timing, Toyota created continuously variable timing that could adjust on the fly. The system used oil pressure to rotate the intake camshafts up to 60 degrees. This sounds simple until you realize the control system processed data 100 times per second. The ECU monitored 14 different parameters to determine optimal cam timing. It could adjust for altitude, temperature, fuel quality, and even driving style. The result? 20% more torque below 3,500 RPM without sacrificing top-end power. But here's what Toyota didn't advertise. The system was designed for boost. Internal documents show VVTi testing with turbochargers producing 500 horsepower on pump gas. The production engine was literally detuned to protect Lexus's reliability reputation. Number 10. The aircraft connection. After production started, Toyota received an unexpected customer: aircraft manufacturers. Experimental aircraft builders discovered the 1UZ offered unmatched reliability for its weight. By 2000, over 200 aircraft flew with Toyota V8 power. The engine required minimal modifications for aircraft use. The deep sump oil system handled extreme angles. The cooling system worked efficiently at altitude. The smooth power delivery eliminated vibration issues that plagued other automotive conversions. One builder flew a 1UZ-powered aircraft across the Pacific Ocean, a 2,400-mile journey over open water. The engine never missed a beat. The FAA eventually certified a modified 1UZ for experimental aircraft. But the wildest application? The U.S. military tested 1UZ engines in unmanned drones. The program remained classified, but leaked documents suggest remarkable success. Toyota never officially supported aircraft conversions, but quietly supplied parts to builders. Number 9. The boat racing domination. Mercury Marine dominated offshore powerboat racing until mysterious Japanese entries started winning everything. These boats ran unmarked engines that sounded different from typical racing motors. When competitors finally got a look, they discovered modified Toyota 1UZ engines. Not purpose-built marine engines, car motors with basic modifications. The 1UZ's closed-deck design handled boost pressures that cracked traditional marine engines. The forged internals survived the brutal pounding of offshore racing. Teams running $100,000 racing engines lost to modified car motors costing a fraction of the price. Mercury Marine actually bought several 1UZ engines to study. They couldn't understand how a luxury car engine outperformed purpose-built racing designs. The secret? Toyota's Overbuilt philosophy created an engine that exceeded racing specifications from the factory. By 1995, every competitive offshore team ran Toyota power. The domination was so complete that some racing series considered banning the 1UZ. Number 8. The 2.4 million mile test fleet. Toyota's durability testing for the 1UZ makes modern validation programs look like quick test drives. The company assembled a fleet of 300 prototype vehicles that accumulated 2.4 million test miles before production approval. But these weren't gentle highway miles. Test drivers had specific abuse protocols. One involved accelerating to redline in first gear, shifting to reverse at 40 km/h, then back to drive. Another required 500 consecutive maximum throttle launches. Engines endured temperature cycles from 40 degrees to 140 degrees. Toyota even tested with contaminated fuel, including diesel accidentally mixed with gasoline. The most extreme test? Running engines without oil changes for 50,000 miles. They wanted to simulate owner neglect. After each test, engineers completely disassembled the engines. They measured every component down to 0.001 inches. Any unexpected wear triggered a redesign. This obsessive testing regime cost millions but created an engine that simply wouldn't fail. Number 7. The German engineer's confession. In 1992, Mercedes-Benz purchased 6 Lexus LS 400s for competitive analysis. What they found shook the entire German luxury establishment. Dr. Wolfgang Bernhard, then a senior Mercedes engineer, later admitted the 1UZ changed everything they believed about engine design. The Mercedes team spent 3 months analyzing one engine. They found design solutions that violated conventional wisdom but worked brilliantly. The variable length intake manifold used a butterfly valve system Mercedes had deemed too complex for production. Toyota made it bulletproof. The timing chain design eliminated the guides Mercedes used, reducing complexity and failure points. But what really stunned them was the manufacturing quality. Tolerances exceeded Mercedes racing engines. Every component showed obsessive attention to detail. Bernhard's team presented their findings to Mercedes management with a stark warning. Toyota has built a better engine than we thought possible. This analysis triggered Mercedes' quality revolution of the mid-1990s. Number 6. The tuner's gold mine. While Toyota never sold a turbocharged 1UZ, the tuning community discovered the engine's incredible potential. The first 1,000 horsepower 1UZ appeared in 1994, shocking everyone including Toyota. The builder used stock internals with twin turbos. The engine survived 18 months of street abuse before requiring a rebuild. This opened the floodgates. Tuners realized the 1UZ's overbuilt design could handle power levels Toyota never imagined. The forged internals, 6-bolt mains, and closed-deck construction created a perfect storm for boost. By 2000, while 500 horsepower builds became common in drag racing. The record? A 2,400 horsepower monster that still used the factory block. But here's the craziest part. Daily driven 600 horsepower 1UZ builds routinely exceeded 200,000 miles. Owners reported better reliability than stock engines from other manufacturers. The tuning potential became so legendary that clean 1UZ engines now command premium prices. Some enthusiasts buy entire Lexus cars just for the engine. Number 5. The production line revolution. Building the 1UZ required Toyota to revolutionize their manufacturing process. The Tahara plant featured innovations that wouldn't become industry standard for another decade. Every engine underwent a 30-minute hot test at full operating temperature. Not a sample, every single engine. This alone added millions to production costs. The assembly line used optical measurement systems accurate to 0.001 inches. Workers underwent 6 months of training before touching production engines. Each builder signed their work, taking personal responsibility for quality. But the real innovation was selective assembly. Computers matched components based on microscopic measurements. Pistons were weight matched to 0.1 grams. Bearing clearances were optimized for each specific crankshaft. This level of precision was unheard of in mass production. German manufacturers used similar techniques only for hand-built AMG or M engines. Toyota did it on every single 1UZ. The result? Production engines with tolerances exceeding blueprinted racing motors. Number 4. The cost-no-object philosophy. Internal Toyota documents reveal the 1UZ program operated without normal cost constraints. Engineers had carte blanche to specify any component that improved reliability or refinement. This led to remarkable decisions that accountants hated but customers loved. The water pump used a ceramic seal designed for nuclear reactors. It cost 10 times more than conventional seals, but never failed. The alternator featured brushes rated for 500,000 miles, double the car's expected lifespan. Every sensor was waterproof to submarine standards. Why? Because engineers wanted the engine to survive floods. The wiring harness used military-spec connectors that cost $12 each versus $50 for standard parts. The engine featured 47 different specialized fasteners, each designed for its specific location. This complexity drove manufacturing costs through the roof. Toyota lost money on every early LS400 sold, but the investment paid off in reputation. When Consumer Reports couldn't find any 1UZ failures to report, Lexus was established. Number 3. The secret supercar project. In 1994, Toyota secretly developed a mid-engine supercar powered by a twin-turbo 1UZ. Codenamed Project 395, it aimed to challenge Ferrari and Porsche. Only 7 prototypes were built before accountants killed the program. But those 7 cars proved the 1UZ's incredible potential. The engine produced 600 horsepower with minor internal modifications. It revved to 8,500 RPM thanks to titanium valves and connecting rods. The car achieved 0-60 in 3.2 seconds and topped 270 mph at Nardo. Why haven't you heard of this? Toyota destroyed all but one prototype and shredded the documentation. They feared it would dilute Lexus's luxury image. The surviving car sits in a secret Toyota collection, occasionally shown to select engineers for inspiration. Test driver Hiromu Naruse later called it the best car Toyota never sold. Technology from Project 395 influenced the later LFA supercar. The 1UZ proved it could power anything from luxury sedans to world-beating supercars. Number 2. The unbreakable legend. The 1UZ's reputation for indestructibility isn't marketing hype. It's proven by extraordinary real-world examples. A taxi in Jordan logged 1.4 million kilometers on the original engine. The owner changed oil every 5,000 km and nothing else. A New Zealand farmer used an LS400 for sheep farming, driving through rivers and over rocks daily. After 500,000 brutal kilometers, compression remained within factory specifications. But the ultimate torture test came from Matt Farah's million-mile Lexus. He bought an LS400 with 897,000 miles and aimed for 7 digits. The car reached 1 million miles with the original engine and transmission. Compression tests showed minimal wear. Oil analysis revealed bearing metals within new specifications. Toyota engineers secretly monitored the project, amazed by their own creation. The 1UZ didn't just meet its design goals, it exceeded them by margins that still seem impossible. No other luxury V8 has proven such anvil-like reliability across millions of real-world miles. And before our final revelation, don't forget to hit that subscribe button for more automotive deep dives and comment below if you knew any of these facts. Number 1. The engine that changed everything. The 1UZ-FE didn't just launch Lexus. It revolutionized the entire luxury car industry and forced established manufacturers to completely reimagine quality standards. When the LS400 debuted in 1989, Mercedes-Benz executives held an emergency meeting after their first test drive. BMW rushed to improve build quality. Jaguar went back to the drawing board. The 1UZ's influence extended far beyond luxury sedans. Its design philosophy inspired Toyota's entire engine family for the next 3 decades. The 2UZ-FE that powers Tundras and Land Cruisers inherited its overbuilt DNA. The 3UZ-FE continued the tradition of bomb-proof reliability. Even the modern UR-V8s trace their roots to lessons learned from the 1UZ. But perhaps the greatest testament to the 1UZ's impact is what happened to the competition. Mercedes developed the M113 V8 specifically to match Toyota's refinement. BMW abandoned their traditional V8 design for an entirely new architecture. Audi finally addressed their reliability issues. The entire luxury car segment improved because one overbuilt engine from Japan embarrassed everyone else. Today, pristine 1UZ engines sell for more than complete cars. Enthusiasts worldwide hunt for these motors to swap into everything from drift cars to rock crawlers. The engine, designed to last 300,000 miles, routinely doubles that with basic maintenance. Some have tripled it. Toyota created something unprecedented, a luxury engine that became a tuner favorite, a motorsport legend, and an engineering benchmark. The 1UZ-FE remains the greatest V8 Japan ever produced, an engine so overbuilt that 3 decades later, we're still discovering what it can do. It didn't just make Lexus untouchable, it redefined what reliability meant for an entire industry.